Hello and welcome to the second module of trigonometry, that is height and distance. I am Mrs. Swati Sharma, Department of Computer Applications, BSSS College, Bhopal. So today I am going to cover introduction of height and distance, line of sight, that is also called as line of vision, angle of elevation, angle of depression, values of trigonometric functions and some examples of height and distance. So let us start with the introduction. Basically, in the last module, I discussed about the applications of trigonometry. So the topic height and distance is one of the application of trigonometry which is extensively used in real life. In the height and distances application of trigonometry, the following concepts are used. It is used to measuring the height of towers of big mountains, determining the distance of the shore from the sea, finding out the distance between two objects. We have some important and basic terms which is used to solve the questions of heights and distance. They are line of sight, that is also called as line of vision, angle of elevation and angle of depression. So these are the terms which we should know to solve the questions of height and distance. So let us start with the line of vision. Line of vision or line of sight. The line which is drawn from the eye of the observer to the point being viewed on the object is known as the line of sight. Let's take one example. For example, in this diagram, you can see that a person is standing in front of a tree. Now he is trying to see the tree. The imaginary line which is drawn from the eye of the person to the tree is called as line of sight. You can see in this picture the red line which is directly connected from the eye of a person to the tree. So this imaginary line is called as line of sight, or it is also called as line of vision. The next very important term to solve height and distance questions is angle of elevation. The angle between the usual line of sight and raised line of sight is called angle of elevation. To understand angle of elevation, I'll take one situation. Let us consider a situation where a person is standing on the ground and he is looking at an object which is at some height, say the top of the building. You can consider it like that. In this diagram, a person is standing here, this is the building, and a person is trying to see the top of the building. So the line joining the eye of the man with the top of the building is called line of sight. The angle made by the line of sight with the horizontal line is called angle of elevation. So in this diagram, you can easily see, let's that object is a building and the eye is the eye of an observer. A line of sight is an imaginary line, and with this horizontal line, an angle which is formed is called as angle of elevation. In simple words, we can say angle of elevation we always find out when a person is looking from bottom to top. The next important term is angle of depression. Now, the angle between usual line of sight and lowered line of sight is called angle of depression. Again, you can see in this diagram, a person is standing on the top and he is looking down. So a usual line, horizontal line or lowered line, that is from person's eye to the boat, imaginary line. Again, to understand this, let's take another situation where the person is standing at some height with respect to the object. Means if object is here and person is standing here, he is seeing downwards. In this case, again the line joining the eye of the man with the bottom of the object is called line of sight. and the angle made by the line of sight with the horizontal line is called angle of depression. You can see in this diagram where a person's eye is on top, means an observer is on top and he is looking downwards for the object. An angle made with the horizontal line on top is called angle of depression. And we can easily say that angle of depression is always outside the triangle, it is not inside, and the opposite or converse angle are equal. So, angle which is inside the triangle will be equal to angle of depression. Now, to find out height and distance, we will see again by using this diagram. To measure height and distances of different objects, we use trigonometric ratios. So, we should know at first what are the trigonometric ratios. I think you are aware with the trigonometric ratios, that are sine, cos, tan, cosec, sec, cot. For example, in this figure, there is a guy looking at the top of lamp post. AB is a horizontal level. The level is the line parallel to ground passing through the observer's eye. AC is known as the line of sight, and angle A is called angle of elevation. Similarly, you can see the next figure. PQ is the line of sight, PR is the horizontal level, and angle P is called as angle of depression. The questions on this topic require basic knowledge of trigonometry. So, you should be aware of the basic trigonometric ratios and their values. Now, values of trigonometric functions are very important to solve height and distance. We should know the values of these 6 trigonometric functions, and these are the standard angle for which you should know the value of each angle, like 0 degree, 30 degree, 45 degree, 60 degree and 90 degree. These are the standard angles, so you should know. Now, I will give you a small trick how you will remember these values. So, for that, at first you should know the value of sine theta. If you know the value of sine, then easily you can find out the value of cos, tan, cosec, sec and cot, as cosec, sec and cot are the reciprocal of sine, cos and tan. So, if you know the value of sine, cos and tan, simply you will find out the reciprocal of these terms to get the values. Let's see, you should know sine theta, sine's value. So, sine value, sine 0 degree will be 0, sine 30 degree 1 by 2, sine 45 degree 1 by root 2, sine 60 degree root 3 by 2 and sine 90 degree 1. So, if you know these values, you have to remember only these values 0, 1 by 2, 1 by root 2, root 3 by 2 and 0. For cos theta, you will simply write down these values in reverse order. Means the value of 90 degree will become the value of 0 degree in cos. So, in reverse order, you will start to write down these values like 1, root 3 by 2, 1 by root 2, 1 by 2 and 0. So, in that way, you will get the value of cos theta. Now, for tan theta, you know that tan theta is equal to sin theta upon cos theta. So, simply you will divide these two terms. So, sin theta 0 degree is 0 and cos theta 0 degree is 1. So, 0 divided by 1, it will be 0, 1 by 2 divided by root 3 by 2. So, 2 to 2 cancel, it will be 1 by root 3. 1 by root 2 divided by 1 by root 2, that will be again root 2 cancel. So, you will get 1. Then tan 60 degree root 3 by 2 upon 1 by 2. 2 to 2 cancel, so it will be root 3, and the value of 90 degree 1 divided by 0, that is infinity, and here the value will be not defined. In that way, you can find out the value of sin theta, cos theta and tan theta, where theta is the angle. It can be 0 degree, 90 degree, 60 degree, 45 degree, 30 degree or any degree. Now if any angle which is not included here, for example, if you have to find out the value of 110 degree. So 110 degree direct value is not given. You need to split this term. We'll see that in some examples. Now for finding out the value of cosec, you just reverse the value of sin theta because it is the reciprocal of sine. So value of 0 degree is not defined. Value of 30 degree 1 by 2 is the value of sin theta. So cosec it will be 2. 1 by root 2 is the value of sin 45. So here it will be value of root 2 because when we find out the reciprocal we will get root 2. In the same way you can find out the values of sec theta and cot theta by doing the reciprocal of cos and tan. Let's see some examples of height and distance. Example first, the length of shadow of a tree is 16 meter when the sun is at an elevation of 60 degree. What is the height of tree? To solve these questions, at first we should understand the length of a shadow of a tree is 16 meter. When the sun is at an elevation of 60 degree, here we are talking about elevation, means angle will be from bottom to top. So angle of elevation is 60 degree. We need to find out the height of the tree. Let's see with this diagram. ABC is a right angle triangle where the length of the shadow, that is AB, is equal to 16 meter. The height of the tree, that is BC, it's x, and angle of elevation, that is angle A, is 60 degree. So at first we will write down what are the given terms. Here AB is given. AB is also called as base, that is 16 meter. BC, that is perpendicular, we need to find out, let it's x. Angle of elevation, that is angle A, is 60 degree. So simply we have to find out at first what values we need to find. We have to find out perpendicular and base value is given. So by using perpendicular and base we have to solve this. So as you know that the value of tan theta, I already told you in the previous module that you need to remember P, B, Pandit, Badri, Prasad, Har Bole. So that is, we will start from sin theta, cos theta and tan theta. So tan theta is equal to perpendicular upon base. So angle, how you will decide the angle? At first you will see that which value we need to find out and which value is given. So here perpendicular find out, we need to find out perpendicular and base is given. So perpendicular upon base is the value of tan theta. Here theta is what? 60 degree, which is given in the question. So tan 60 is equal to perpendicular value is x divided by 16. And what is the value of tan 60 degree? It is root 3. So root 3 is equal to x divided by 16. So what will be the value of x? X is equal to 16 root 3 meter. So the height of the tree is 16 root 3 meter. Now if you want, you can put the value of root 3 here or you can leave it like that. So the height of the tree is 16 root 3 meter. Let's take one more example. In this example, again we have to find out the angle of elevation of the sun when the shadow of a pole of 18 meter height is 6 root 3 meter long. We have to understand the question at first. In this, we need to find out angle of elevation of the sun. Now here angle is missing. When the shadow of pole of 18 meter height is 6 root 3 meter long. So here this is the pole which is having the height of 18 meter. Its shadow is 6 root 3 meter long. So we need to find out the angle of elevation. Now you can see in this diagram where the height of the pole is 18 meter and the shadow is 6 root 3 meter long. We need to find out the angle of elevation. So perpendicular is given 18 meter, base is given 6 root 3, angle, that is theta, we need to find out. So here again perpendicular and base is given, means by using perpendicular and base we have to find out theta. So tan theta is equal to perpendicular upon base. Value of perpendicular is 18 divided by 6 root 3. When you solve this, you will get 3 root 3 upon root 3 or root 3. So root 3 is the value of 60 degree in tan. So tan theta is equal to 60 degree. In this way, you can find out the missing angle. Again, to find out the angle, firstly you have to see that what is the given value. Perpendicular given, hypotenuse given or base given. Accordingly, you will select the trigonometric function. Another example I am taking. The example is, from a point P on a level ground, the angle of elevation of the top of a tower is 30 degree. If the tower is 100 meter high, then what is the distance of point P from the foot of the tower? Now in this example, angle is given 30 degree, height of the tower is given 100 meter, and we need to find out the distance from point P to the foot of the tower. That means we need to find out base here where perpendicular and angle is given. So again in this question, you will see perpendicular and base value is we have to find out. So angle is 30 degree, angle of elevation is 30 degree given. Perpendicular is 100 meter, angle is 30 degree and base we need to find out. So by using perpendicular and base, again it is tan theta. So theta is 30 degree. Tan 30 degree is equal to perpendicular's value is 100 meter upon base value. So you can write it base only, or if you want you can take any variable you can assume as a base. So here I am taking 100 divided by base. So the value of tan 30 degree is 1 by root 3 and which is equal to 100 upon base, because base is not defined, we need to find out that. And when you solve this, you will get base is equal to 100 root 3, or it is also called as 173 meter. When you substitute the value of root 3, so 100 into root 3, you will get 173 meter. Thank you for watching this video.